Welcome back. Today we're going to cover the topic of systems of equations, and we're going to look in particular with equations where one is a quadratic equation and the other one is a linear equation. Okay, so in general, there are three numbers of possibilities of solutions. Remember, when we look at systems, what we're interested in is we're looking at the points of intersection. So a parabola and a line can intersect twice, meaning there are two solutions to the system. It can intersect one time, meaning there's one solution, or they don't necessarily have to intersect at all. So if the parabola is going above the line and the line will never meet the parabola, then there's no solution to the system of quadratic and linear equations. Okay, there's two methods we're going to go over how to solve. Now, one method is using the graphical method, and we've done this before with lines, and we've actually done it before with a quadratic and a linear equation. Just the lines that we normally use are horizontal lines. So sometimes we will, in order to find a solution, we'll graph the quadratic and we'll graph a horizontal line, and we'll look at the point of intersection. And this is almost identical. So first of all, let's go ahead and graph this line. All right, it has a y-intercept of -4 and a slope of 1. So here we have this line here. Okay, pick up my line tool and make it nice and neat and long. Right, always make the line as long as possible here, because you never know where the parabola is going to hit it. Right, so let's go like this. And when you're doing systems of equations, always label your equations on the function label for whatever you're graphing, whether it's a line or a curve. All right, now in order to graph this, well, one thing I know that it has a y-intercept of 6. So that's going to go up here, but I don't know any other point. So what I'm going to do instead is I'm going to pick up my graphing calculator and go to my y equals, and just go ahead and put this in. Y equals x squared minus 6x plus 6. Okay, let me go ahead and graph this. Okay, and while I'm at it, actually, I'm going to go ahead and graph x minus 4, just to get that in there. Okay, just give an understanding of where I think they should meet. Okay, so it looks like they meet, one of them's in quadrant 1, and another's in quadrant 4. It looks like it's -2, 2, -2 maybe, and maybe 1, 2, 3, 4, 5, and 1, but I'm not entirely sure. So we're going to check it out, especially, and by the way, you should make sure that if you're asked to graph it on the regents, you don't just graph on your graphing calculator. You need to represent these graphs on whatever graphs they gave you on the paper. So let's go ahead and use our table to pick up a few values of interest here. So y1, that was the quadratic equation. You can see it right here. So let's pick up 0, 6. We said that before. 1, 1, 2, -2, and 3, -3. So we have 0, 6, 1, 1 is here. 2, -1, 2, and that is where it meets. And we had 3, -1, 2, 3. Okay, and I think that that's our vertex. Let's see. Oh, our graph is not coming up here. All right, here. So 3, -3, and that is our vertex because you can see it goes down and then it starts coming back up after -3. So that's the lowest, that's the minimum value. It's opening upward here. So we have 3, -3, and so here is our line of symmetry. So what we can do is just sort of graph these on the other side. So that's that point on the other side. This is 1, 2 away, so we go 1, 2 away here. And again, that's the other point where it's going to meet right there. There's 1, 2, 3 away, so we go 1, 2, 3 away. And we try to, as smoothly as possible, draw the branches of the parabola. Okay, and then we'll label it f of x. Okay, so here, there are the points of intersection here. This is 5, 1, and this is 2, -2. Remember, the points of intersection are the solutions to the system, so they're always coordinate pairs. It's not just an x value. What we can do is we can go ahead and check. So let's go, let's put 5 in here. We'd have, actually, you know what? It's a little easier to check here. Since I've graphed them both together. So here, there's a couple different ways I can check. I can look at 5, for the x value of 5, both functions are 1, so that's good news. For the x value of 2, both functions are -2, so that's exactly where they meet. We could have also gone to the graph and asked it to calculate, so second trace, calculate the intersection, which is 5. It's asking me for the first curve here, and yes, I want the quadratic equation to be my first curve. I say yes. And then it's saying, do you want the second curve to be the line? You say yes by pressing enter. And guessing tells you, gets you the intersection that you want. So here I'm going to put the intersection near the first one, or the cursor near the first intersection. Press enter, and it would derive that 2, -2. If I wanted to get the other one, I would do the same process by saying yes the first curve, yes the second curve, but I would arrow over, I'd use my right arrow key to arrow near the other point of intersection. I'd press enter. It doesn't have to be exactly on, just near it. And it gets me that 5, 1. All right, so that picked up both of them. Okay, in order to do solving systems algebraically, what you're going to have to do, and again, you could go ahead and put this in on your graph and figure out what the solutions are, and then use that to sort of work backwards algebraically, but you will not get full credit if you're asked to solve a system algebraically and you do it graphically, especially on your graphing calculator. So even if I drew a nice graph here, if it said do it algebraically, you're not given full credit unless you do it that way. So the trick is here, and what you want to remember is what you're looking for is you're looking for x and y coordinates where the two functions are equal. So what the first step is you're going to set them equal to each other. So x plus 1 quantity squared minus 4 is equal to 2x minus 2. Notice the thing that's dropped out here is our y value. So what we're going to get is we're going to get an x value, we're going to put it back into the function and get the y values. And we should expect to get 2 points of intersection, okay? Although 1 and 0 points of intersection are also a possibility. All right, so here I'm just going to go ahead and square this binomial. So this is x squared plus, so it would be 2x plus 1 minus 4 is equal to x minus 2. Remember that a common mistake here is taking this and just saying that it's x squared plus 1. That's absolutely incorrect, right? You don't just square the terms in the binomial. You actually have to work it out. So x plus 1 times x plus 1, you'd have to take x and multiply it by x plus 1, and 1 times x plus 1, and it should get you this right here. Okay, let's clean this up on the left-hand side here. So we have x squared plus 2x minus 3, and that's equal to 2x minus 2. Now we're back in module 16 where we're trying to figure out how to solve this quadratic equation. So what I'm going to do is I'm going to use the zero product property because it's my favorite way of solving a quadratic equation. I'm going to bring all my terms over to the left and set my right equal to 0. So if I subtract 2x and add 2 to both sides, I should be able to get what I need. Okay, so here my right side gets 0. And my left side is x squared, and these knock out, so we just have x squared minus 1 equals 0. So remember, this is actually the difference of squares. So we have x minus 1 and x plus 1 is equal to 0. So what I do is let's see. I make two equations. I make the equation x minus 1 equals 0, and then x plus 1 equals 0, and I solve them. Here x is equal to 1, and here x is equal to -1. So these are my x values. What's super important is that solving this quadratic equation is only one step of this process. It's a problem within a problem. So we're not finished here like we used to be. Instead, we have to go and we have to put them back into the equation to come up with the y value, because it's a system of equations and the solutions to systems are coordinate pairs. Okay, so if I have it, so I'm trying to find g of 1 here. So if I put 1 plus 1, so it'd be 1 plus 1 quantity squared minus 4. Well, that would be 2 squared is 4. That would actually equal 0. So g of 1 is 0. Let's just check that h of 1 is also 0. That would be 2 times 1 minus 2, and again, that's going to be equal to 0. So first coordinate pair is 0, 1, 0 rather. All right, let's look at g of -1. That would be -1 plus 1 quantity squared minus 4. Well, that's going to be 0 squared minus 4, which is -4. Okay, let's just make sure h of -1 is also that. So we have 2 times -1 minus 2. So I have -2 minus 2, which is -4. So my other coordinate pair is -1, -4. And if I graph them, so like right now, if I were doing the regions and I had already figured these things out right here, what I would do is I'd go ahead and graph them to make sure that these are solutions, okay? Except, you know, I've already put them in to make sure, but if you really wanted to, if this was a question that had a lot of points associated with it, you might want to go ahead and check it. So you can just go here, clear both of them out and put them in. So we have x plus 1 squared right here minus 4, and then the other one is 2x minus 2. And let's graph them. And they should meet at, let's see, -1, -4, good, and then there's 1, 0, right? And so that's the end of the lesson for today.